Hello, algebra students. I am continuing to go over the Unit 5 practice test. So in this video, I will be going through the rest of the packet, numbers 16 through 23. So for number 16, solve the system of equations, I feel like I should say. So we want to substitute for y. They both have y equals on one side. Y is isolated. So when it's like that, you set the two functions equal to each other. X squared minus 4 equals negative x minus 2. And then we want to get all of the terms on one side, so we want to get it equal to 0. So we want to move all the terms over to the side with x squared. So look at the side that does not have x squared, which is this side, and we want to move these terms. So we want to do the inverse. So if it's minus x, I'm going to add x, and then minus 2, we're going to do plus 2. Now combine like terms, there's nothing to combine to x squared, so I leave that the same. There's no other term with just x, so that also is the same. And then negative 4 plus 2 is negative 2, and it's equal to 0. Now I can solve this quadratic function by using one of the methods. So I'm going to try factoring because this b value is 1x, and then my c value is negative 2. And I know if I multiply 2 times negative 1, that equals negative 2, and 2 plus negative 1 equals 1, so I'm going to use those. X plus 2 times x minus 1 equals 0. Then I set each of these binomials equal to 0. X plus 2, inverse is minus 2, x equals negative 2. Minus 1, the inverse would be plus 1, x equals 1. We are not done yet though. I need to find out the ordered pair for the solution. So I need to go back to my system of equations and substitute for x. I'm going to use the second equation. That one just seems easier without the squared. I mean, the squared one isn't that hard, but negative 2. So I'm going to do y equals negative times negative 2 minus 2. And negative times negative 2 is positive 2. 2 minus 2 is 0. Y equals 0. And then for x equals 1, y equals negative times 1 minus 2. Negative 1 minus 2, negative 3. So my solution ordered pairs would be negative 2, 0, and 1, negative 3. Number 17, same thing, solve the system of equations. So they both have y equals, so I'm going to set them equal to each other. X squared minus x minus 6 equals 2x minus 2. I look at the side that does not have x squared. I want to move those terms over by doing the inverse. Combine my like terms. X squared minus 3x minus 4 equals 0. Again, I kind of noticed that factoring might work. Negative 4 times 1 equals negative 4, and negative 4 plus 1 equals negative 3. So x minus 4 times x plus 1 equals 0. X minus 4 equals 0. X plus 1 equals 0. Inverse, add 4 to both sides, x equals 4. Subtract 1 from both sides, x equals negative 1. Go back to my systems and substitute. I'm going to use the second system. Y equals 2 times 4 minus 2. 2 times 4 is 8, minus 2 is 6. And then y equals 2 times negative 1 minus 2. 2 times negative 1 is negative 2. Minus 2 is negative 4. All right, so now my solutions, my ordered pairs, this was x was 4, y was 6, 4, 6, and then this one, x was negative 1, y was negative 4. Determine if each statement is always, sometimes, or never true. Explain. So for this one, a system of equations that contains a quadratic function and a linear function will have 2 solutions. Well, this can be true sometimes, but we also could have a quadratic and linear function that never touch, so they have no solutions. So this would be sometimes true. And if I draw a couple examples to visualize it, I could have like a quadratic function like that, and then a linear function that goes here. There's no solution. They would never touch. So for these, there's no solution. Whereas I also could have one like this, and they could have 2 solutions. So sometimes true. B, a system of equations that contains 2 linear functions will have no solutions. Well, that can also be sometimes true. Because 2 linear functions could be perpendicular to each other, so they could have 1 solution, but they also could be parallel and have no solution. So like if I have one linear function going this way and one going this way, that's 1 solution. But then I could also have parallel lines where they have the same slope, and this would have no solutions. So that's sometimes true. So these would be parallel, perpendicular. And remember, with perpendicular lines, they would have one positive slope and then one would have a negative slope. And then for the parallel lines, they have the same slope, but different y-intercepts. C, a system of equations that contains a linear function and an exponential function will result in an exponential function with output values that are less than the linear function's output values. So again, this I would say is sometimes true, because at first the exponential function's output values are going to be less because it starts off slower, but then eventually it will always surpass the linear function. So sometimes true because at first it will be less. Because if we also draw a graph and we show how at first it's that gradual start, and then if I have a linear function that starts at the same point, at first that J-shaped, that exponential function will be less, but then it's always, at this point, it's the same, and then it's always going to be much greater because it's going to exponentially grow at a very fast rate. So sometimes true because at first it will be less. D, when graphed, a quadratic function opens upward. That is also sometimes true because that's only if the a value is greater than 1, or actually greater than 0 if it's positive. So if the a value is positive, it opens up. But if the a value is negative, it opens down. So we could have opening up or opening down. E, the solutions of a quadratic function are the x-intercepts of the function. This is always true. Now, it may not have any x-intercepts and it may not have any solutions, but the solutions are still always going to be the x-intercepts. So if we had one, these solutions would be here on the x-axis. F, quadratic functions can be factored. Again, this is sometimes true because, as you've seen before, there are quadratic functions that are not factorable, and we have to use a different method. Not always factorable. Identify the solutions to each system of equations graphed below. The solution is when they both intersect. So at this point, it would be 1, 3. That would be one solution. For this system of equations, systems of graphs, there would be two solutions. This one's at -1, 3, and the other one is at, so if one's here, it's at 1.58. So this one has two solutions. Little Crispy fires a rocket from his roof. The function k of x equals -3x squared plus 12x plus 16 describes the height of the flight in feet of the rocket in x seconds. 20. Determine at what times was the rocket's height greater than 16 feet. 21. How long was the rocket in flight? 22. How long did it take the rocket to reach maximum height? And 23. What was the rocket's maximum height? So I know that with these questions, I need to find the vertex to get the maximum height and how long it took to reach the maximum height. I know that I need to find the x-intercepts to find out how long the rocket was in flight, and then I need to use the equation in multiple points so I can graph it to also find when the height was greater than 16 feet. So I'm going to show all my work at the bottom here. So I'm going to start with the graph. I'm going to label it so I would have time in seconds on my x, and then this would be the rocket's height on my y, and that was in feet. Okay, so I want to find the vertex. So to find the vertex, I first need to find the axis of symmetry, -b/2a. So going to my equation, my b value is 12, so -12/2, and then my a value is -3. -12 divided by -6 equals +2. So I know x equals 2. Then I plug 2 into the equation for x, -3 times 2 squared plus 12 times 2 plus 16. 2 squared is 4. 12 times 2 is 24. -3 times 4 is -12 plus 24 plus 16. -12 plus 24 is +12. plus 16 is 28. So my vertex is at 228. So I'm going to label my graph with the numbers so I can start graphing it. So if I count by ones on, oh, I don't like that. That's going to be too cramped together. I'm going to spread these out more. I'm going to skip a line in between each one. So 1, 2, 3, 4, and 5, and 6. And then for my height, I know that my highest point is at 28 feet, so I'm going to count by fours. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Okay, so I know that I'm going to put my vertex at 228. I also can tell just by looking at the function that my C value is 16, so my y-intercept is 0, 16. And then I know that at x equals 2, this is my axis of symmetry. So if I just draw like a dashed line down the middle of this, all of my points are going to be symmetrical on each side. So I need to find out when the rocket's height will be greater than 16 feet. I know the starting point was at 16. So if I go from my axis of symmetry, 1, 2, 3, down 3, and then 1, 2, 3, 4. Well, if I go the opposite direction, 1, 2, 3, 4, I also know that the rocket's height will be at 16 feet at 4 seconds. So I know it'll be from 0 seconds time to 4 seconds. So that could be my answer for number 20, between 0 to 4 seconds. It's asking when it'll be greater than. It doesn't say greater or equal to, so if I made an inequality, it'd be 0 is less than x, which is less than 4. So because it's not saying greater than or equal to, we would just use the symbols without the or equal to. So this is saying x is greater than 0 and less than 4 in order for it to be 16 feet. 21, how long was the rocket in flight? So I also need to find my x-intercepts so that I know when it's going to hit the ground. So for this one, I'm going to use the quadratic formula. So if I plug in my values, so I know A is -3, B is 12, C is 16. So for the quadratic formula, x equals -b, so -12 plus or minus 12 squared minus 4 times A, which is -3, times C, which is 16, divided by 2 times -3. All right, then I solve. 12 squared is 144. And then if I multiply -4 times -3, that's positive 12. 12 times 16 is 192. 192 plus 144 is 336. So that would be under the radical. 2 times -3 is -6. Then I need to find the square root of 336. So that's about 18.33. So x equals -12 plus or minus 18.33 divided by -6. And then set my two equations. X equals -12 plus 18.33 divided by -6. -12 plus 18.33 divided by -6 is 1.055. Now for this one, time is our x value. Negative time does not make sense. So for this graph, if we continued the parabola, it would hit over here in the negative. But that is not realistic or reasonable for this situation. So I'll write it. But this is not reasonable. So we're not going to graph it or answer that one. So then I need the other equation, x equals negative 12 minus 18.33 divided by negative 6. So negative 12 minus 18.33 divided by negative 6, 5.055. X equals 5.06 about. So I know that it will be in flight for about 5.06 seconds. Because it started at 0 seconds, was in flight. So I can draw my parabola. How long did it take the rocket to reach maximum height? Well, I know my vertex was at 2 seconds. It was 28 feet. So 2 seconds. And what was the maximum height? 28 feet. Thank you so much for watching my video. I hope this helps. And you're going to do awesome on the test.